In this video, we'll be developing the Pythagorean identities. Using this reference triangle, we can use the Pythagorean theorem to set up an equation. We know that x squared plus y squared equals r squared. Now we like an equation with our trig ratios, so I'm going to divide through by r squared. And we have then x over r quantity squared plus y over r quantity squared equals 1. Now we're able to sub in place of x over r. We know that this is cosine of theta. So this is cosine of theta, and that's squared. So cosine squared plus, and then y over r would be sine squared of theta equals 1. We can also subtract sine squared from both sides and get another expression. So I have cosine squared theta is equal to 1 minus sine squared theta. And then if I subtracted cosine squared from both sides, I would have sine squared theta equals 1 minus cosine squared theta. So basically, if you memorize sine squared plus cosine squared equal 1, you'll have these at your fingertips just by algebraically manipulating the original. What if we wanted an expression with a tangent in it? Well, we know from our quotient identity that tangent is sine over cosine. So I can divide everything by a cosine squared. And I will get 1 plus tangent squared theta equals secant squared theta. So this is another Pythagorean identity. And I can also subtract tangent squared from both sides. I get secant squared theta minus tangent squared theta equaled 1. And I can subtract 1 from both sides up here. And I can get then tangent squared theta equals secant squared theta minus 1. So we've used sine squared, cosine squared, tangent squared, secant squared. Let's develop one with a cotangent in it. And again, I'll start with my sine squared theta plus cosine squared theta equals 1. And if I want a cotangent in it, I need to divide everything by a sine squared here. So this is 1 plus cotangent squared equals cosecant squared. So I could subtract cotangent squared from both sides. Or I could subtract a 1 from both sides. So those are the Pythagorean identities.